Complex circuits are exactly what it sounds like. It's a combination of series and parallel resistors. So they can either look like this, where you've got basically a parallel resistor, but within one of the branches or two of the branches, you have resistors in series. Or it can look like I've got things in series, but one of the series is actually branched off into a parallel. Again, the overall strategy remains the same. I find my REQ, then I find my VEQ, and I collapse it into a simple circuit to find the total I. Then I re-expand it backwards in reverse. So if I collapsed it first as a series and then parallel, where I find these first and then I find the parallel, I'm going to re-expand it in parallel and then in series. Again, it'll make more sense when we go through this. So example A. This is an example where I have two parallel things and one of the branches has series. So this is my original circuit. So the first thing I'm going to do is I'm going to try and combine these into something of an equivalent of one resistor. Okay, so this is in series, and I know that's in series because I have to go through both of them at the same time. I don't have a choice. So this 4 ohm and this 8 ohm are the equivalent of one 12 ohm resistor. So I can rewrite these two resistors as one 12 ohm resistor, and now I have two resistors in parallel. So now I have to use the parallel resistor equation, which is 1 over Req is equal to 1 over 6 plus 1 over 12. Least common multiple is 12, so 2 twelfths plus 1 twelfth equals 3 twelfths. I have to flip it. That becomes Req is equal to 12 over 3, which is equal to 4 ohm. So this circuit right here with two resistors in series across from one that's not is the equivalent of one power source of 60 volts with one resistor that's 4 ohms. So the total current that's going through this is 15 amps. Now I work backwards and I begin to re-expand. So I had collapsed it first from series, and then I tackled these two things that were in series, and then I tackled the resistors that were in parallel. So now I'm going to start with parallel. I'm going to bring it back to this point where it looks like it's just two resistors in parallel. And I'm going to say, all right, whether I take this green loop or this loop with the red, then I'm going to have to drop the same voltage. So each of these are going to drop 60 volts, right? So this 6 ohm resistor has to drop 60 volts, so a 10 amp current is going to go through this. I just deal with a 6 ohm resistor here because the red set is still combined. But I now know that 10 amps worth of current go through this from the original 15 amps. Well, if the 10 amps are going through here, then that means that the current that's going through here is 5 amps, right? I started out with 15 amps, 10 amps goes this way, so that means 5 amps go this way. And that's going to be constant through both of these because in a resistors in series, the current remains constant. So both of these will have a current of 5 amps. The 4 ohm resistor will have a drop in voltage of 20 volts, and the 8 ohm resistor will have a voltage drop of 40 volts. These two together equal 60 volts, which it has to because whether I take the green branch and go through one resistor, or whether I take the red branch and go through two resistors, my total voltage drop has to be the same as the total voltage drop here. So remember, in parallel circuits, the current splits, but the delta V is constant. So I use delta V divided by R to find I. In series, the I is constant, and so I have to figure out what the delta V is by multiplying I times R. Example B is when I have two things that are in parallel, but it's also connected to something in series. So here I want to resolve the parallel part first. So, because once I do that, I can just simply add it to my 8 ohm resistor here, right? So I have a 6 ohm and a 12 ohm. Combine these in parallel. 1 over Req is equal to 1/6 plus 1/12. Least common multiple is 12, so it's 2 twelfths plus 1 twelfth. 1 over Req equals 3 twelfths. Flip those because I have to take the reciprocal, so Req is equal to 12 over 3. Simplify, so Req is equal to 4. So now these two red resistors that are in parallel are the same as one resistor that's 4 ohms. So then I now plug it back in here. So this now is the same as this. So now I can say, oh, these are just two resistors in parallel. I can just add those. So the REQ will be 8 ohms plus 4 ohms, which makes it 12 ohms. So this complicated circuit here is the equivalent of one simple circuit that has one battery that's 72 volts and one resistor that's 12 ohms. In that situation, I can push through a current of 6 amps. So now I have my 6 amps and I re-expand it, right? So if my last thing was to deal with the series resistors, I'm going to go back to that step right before. This green stays constant. So my current 6 amps here goes through an 8 ohm resistor. My voltage drop is going to be 48 volts. That means that that 48 volts of the original 72 volts is used up here, leaving me with 24 volts to go through this set of 4 ohm resistor thing. I take this 72 volts here, which is my original. 48 of those get used up in my first resistor, so I only have 24 volts left to go through. And it's left to go through either one of the branches, right? So whether my journey takes me through this 8 ohm resistor and this left-handed red resistor, or the 8 ohm resistor and this right-handed red resistor, I always have to go through this 8 ohm resistor, and the remaining voltage I have to work with is going to be the 24 volts that was left over. So now that I have my delta V, it's going to be 24 across each resistor in parallel. I use V divided by R to get my current, and I have 4 amps going through this and 2 amps going through this. And both of these should add up to the original 6 amps, right? So then I have everything. When I add up my total voltage, whether I go through this 48 and then this upper one plus 24 equals 72, or I lose 48 volts here. To my left branch, 24 volts here, I lose 72 volts. I started out with 6 amps of current. It split. 4 went this way, 2 went this way, but they combined to go back to 6 amps over here. So it's still using the same series and parallel. You just have to figure out which one you're going to do first. And whatever you do first, you do the reverse order when you're re-expanding.